So hello, you're welcome back. In this video, we'll be looking at change of base. So here, basically, you want to change from one base to another, and it's not difficult to do. Let's just motivate it here. For example, if you have y, let's say if I have y log to base a of x, right? And this is what we have, and then we want to change this to another base. Let's say we want to change this base to what? To b. So all we need to do, we can change it to exponential form. So we can write this a to power y is going to be log to base what? This is going to be just x, right? So we've changed from logarithmic form to exponential form. Now, if I want the log, you can see here, what is the log to? This is log to base a of x. But now the goal is that I want to change this a to become b. So what I will do now is we'll take the log to base b of both sides. So this is log to base this, and what will this be? This will be log to base b of x, right? So we just take after we change this to exponential form, take log to base b of both sides. But this y will come down, right? Based on the power rule. So this will become y log to base b of a. And this is nothing but log to base what? To base b of what? Of x. So we can find y. What is y? We can divide both sides. We can now divide both sides by log to base b of a, log to base b of a. So this and this will cancel. So our new y is now log to base b of what? X over log to base b of a. So now please notice this one here. You will notice that things have changed here. The base have changed, right? Look at the base here. The base for y here used to be x. But if you go back here, this is now look at the base. The base now become b because now it's log to base b of x. Before here, it used to be log to base b, log to base a of x. But now it has become log to base b of x. So it means the base has changed. But if you look at here now is also log to base b of what? Of the older, our old base, which used to be a. So this is how we will do change of base. Let me just give you a quick example. So a quick example is this. If I have log to base 2, I have log to base 2, and we want to go to base 3. So if we have log to base 2 of x, and let's say I don't like this base 2, I want to take it to base 3, all you need to do is, this is going to be log to base what? 3, that base that you want, of x, divide by what? Still log to base 3, and of your old base, what is the old base? Is 2, and that is it. So this is how to transform from one base to another. Okay, so in general we have some stuffs here. So here, if you have this is always true. If you have log to base a of x, you can write it as what? Log to base b of x. This is the normal one, which we just discussed, and this is log to base b of a. So in this case, we have transferred from base a to what? To base b, right? Okay, so, but what is this? This is when you go from a to any base. But if you go from a to base 10, you're just going to leave it like this. For example, if I want to convert from base a to what? To base 10. So it means you have log to base a of x. If I want to go to base 10, it's just going to be log to what? Remember, it's going to be log to base what? 10 of x over log to base 10 of the old base, which is what? Which is a. But we know we don't write log to base 10. We just leave it without log. So this just becomes log x over what? Log a. So that is why we have this part. Is that okay? Now, this, we can also write it as what? Ln x over what? Over ln a. Why? This is just like changing from base a to what? To base e. So let me do it here. If I have log to base what? To base a of x, and let's say my goal is to go from a to e. So what will this be? Remember, this will be log to base e of x over log to base e of what? Of the old base, which is now a. But what is this one? What is log to base e? It's just ln. So you have ln x over here also is going to be ln of what? Ln of a. So this is just the explanation how to move from this base. So you can move from base a to any base, either b, you can move to base 10. If you move into base 10, you use this. If you are moving to base e, you use this one. Okay. All right. Now, there are also some very interesting facts that we should know how to play with here. I'll just explain them briefly here. These are additional properties. Look at this one. Property 1, we call it fact 1, fact 2. So it means that if you have 1 over, please look at it, 1 over log to base a of x, what can we do? It's the same thing as what? Now, what is changing? Look at what is changing here. What is changing is that we are changing from what? Base A, but here now, what is the base? Base X. So you are changing from A to what? To X. So just forget it. Just write this. How do you show this one? This is going to be 1 over, this is this one. If I change from A to X, this is just going to be log X of what? Of X, right? Divide by log X of what? Of A, just by change of base. So what I did here is just to move from which base? It's just to move from base A to what? To base X. So we just change base A to X, right? So, and from here, it's easy to see. So we can see from here that this is nothing but what? 1 over, this is log to base x of x is just 1. So this is 1 over 1 log of x of a. And what is the meaning of this? This is just change division. This is 1 over 1 times what? Log x over a. So our final answer is just log x over a. Please see this one. So this is this number 1. So it means that if you have, so I'm just still explaining 1. So if you have log to base what? 2 of 3, or let me not use it. You have 1 over what? Log to base what? 2 of 3. Just interchange. Let the base become the exponent, right? Or become the argument. This will just be log to what? Log to 3 of what? Of 2. Just interchange. It's clear? So this is an application of this property. All right. Now, let's see the second one as well. So the second one is still the same. You have log to, let me use a different pen here. So we want to show the second property. Okay, so let's hope this works now. So you have log to base what? So if you look at the second one, we look at the second property now. What is the second fact? Is this one here. If you have log to base, so just take a look. What is actually happening? Here you have log to base. The base here is 1 over a. So you can change it to base a, right? You can change it to base a. So you want to go from 1 over a. So what we have is you have logarithm to, yes, this is what we have. And now we want to change this base to what? We want to change 1 over a. So let's put it this way. We want to change 1 over a to a. So what do we write? This will just be the base that you are interested in. You are interested in a. So just put it a here, right? Then you put the argument, which is still x. Then you divide by what? Log to base, your new base and your old base, which is 1 over a, right? And what is this? This will just give us log to base a of x over, but what is this one? Don't forget that this is just going to be log to base a. 1 over a, you can write it as a to power minus 1. And now this will be log to base a of x over, this is minus 1. Minus 1 comes down, so you have log to base a of what? Of a. And this is simply log to base a of x over just minus 1, right? Because log to base a of a is minus 1. And this is simply, this minus can come up, so you have minus log to base a of x. Now, this is what we have. So here, if you look clearly, this is the second part here. So it means now we have shown from where? We have shown from here to here. But you can also move from here to here. All you need to do is to take this minus 1 up. And it becomes what? It becomes 1 over x, right? So let's see that here. So it means that this, you can just write it as log to base a of x to power, this minus 1 can go up, minus 1. So this you can write as log to base a of 1 over x. All right. So let's look at the third one. The third one is just the generalization of the second one. So it means that, so here, let me just give you a typical example. So it means if you have log to base what? Half of x, it's just what? Based on what we've written now, this is the same thing as minus log to base 2 of what? Of x. This is always true. Or you can also write it as what? You can say this is log to base 2 of what? 1 over x. So this is just application of what we just saw now, the second part. Now, let's look at the third fact. The third fact is just a generalization. And what does it say? It said if you have log to base a of k, it's just what? 1 over k log to base a of x. And then you can take the 1 over k up. So it's similar to what we discussed here. So what we're saying is if you have log to base what? A to power k of x. So what will happen? The same thing. So here now you want to change your base from a to power k to a. So this is going to be log of what? A of x over log of still a, but your old base is a to power k. And now following the same step as what we did, this is log a of x over k will come down. So you have log what? A of a. So this is going to be log of a of x over what? Log A of A is what? Is A. So this is K times 1. So this is just log of A of X over what? Over K. So which we can write as 1 over K log of AX, right? And this 1 over K can go up. So you just have log of A x to power 1 over K. So you see, it means that if you have log of A to power K of X, you can write it as what? As this one, as just 1 over K log of A of X, and it is still the same thing as log of A x to power 1 over K. So this is another fact. All right. So here now, let's go and see some applications of these stuffs here. All right, so let's start with this one, example 6. It says, given that log to base 2 of 3 is what? Is A, and log to base 2 of 5 is B. We want to write log of what? Log to base 36. No, log to base 10, because you can see that the base is missing. So that simply means that you are dealing with what? We are dealing with which laws? We're dealing with the base 10, right? All right, so if we're dealing with base 10, what can we do with base 10? Here, all you need to do is we now need to change base, because everything we are given is actually as what? As base 2. So let's see how we can handle this one. So this is what we're saying. You're actually giving log to base what? Log to base 36, which I can write as log to base what? 10 of 36. But now, if you look at everything you are given, we're given everything in terms of log 2. So it means we have to go from base 10 to base 2. So to go from base 10 to base 2, we can write this as log to base 2 of what? 36. Then now log to base what? Log to base 2 of the old base. What is our old base? 10, right? And now this will be log to base 2 of 30. This is what? 36. Now, how can we write 36? We can write 36 maybe as what? We can write it as 6 to power what? We can write it as 6 to power 2, if we like. So we can write it as 6 to power 2. Then here is what? Log to base 2. But log to base 2 of 10, we can write it as, we can write 10 as 2 times 5. Why are we doing that? Because we know we have 5. We can, anytime we have log base 2 of 5, we can put B, right? So here, we can write this as what? This is 2, will come down. So you have 2 log 2 of what? Of 6 over log 2 of 2 times 5, right? You can see that. But these, we can also write this 6 as what? As 2 times 3. So this can become 2 log 2 of 2 times 3 over log 2 of 2 times 5. And now we can have a 2, put the brackets. We can change this multiplication now so that you have log 2, 2 plus what? Log 2, 3 over. Here we can write these as also log 2, 2 plus log 2, 5. I think we can do this. This is one way we can do this now. This is 2 brackets. Log 2, 2 is 1 plus Log to base 2 of 3. Log to base 2 of 3 is already given. Log to base 2 of 3 is a from here. So this is a over. Now log to base 2 is 1 also, plus log to base 2 of 5 is what? Is b. So we will have this answer. All right, so let's explain it again. Just go from where? Because you here is log to base 10. But what we are given is log to base 2. So you need to go from 10 to 2 first. And how do you go from 10 to 2? This will be log to base 2 of 36, then log to base 2 of what? Of 10. Then you can write 36. You can write 36 as what? You can write it as 4 times 9 if you want, if you wish. You don't have to write it as 36. So from here, you can write this as log 2, 4 times what? 4 times 9 can do the job, over what? Log 2 times 10. And here you can just write it as log to base 2 of 4 plus log to base 2 of 9. And here also you can just write it as log to base 2 because this is 10. We can write 10 as 5 times 2. So this is log to base 2 of 5 plus log to base 2 of 2. Now, this part, this is, you can write as log to base 2 of 2 square plus log to base 2 of what? 3 square, yes? Over log to base 2 of 5 plus, this is going to be definitely 1. As you can see, this is going to be 1. And here, log to base 2 of 5 is just going to be b. So you see, you already have b plus 1 in the denominator, which is the same thing as 1 plus b. And here, you can write this as what? 2 log to base 2 of 2. And this also you can write 2 log to base 2 of 3. Everything b plus 1. So here you can see this will be 2 times 1. So you have 2 plus log to base 2 of 3 is a. So this will be 2a over b plus 1. So it's the same thing. You can factor out a. So this is another approach which can lead you to the same answer. And this is another. So depends on how you able to split. Here, we split 36 as 4 times 9. You will arrive at the same answer. Or you can write 36 as 6 square. Then you take the 2 down. Then later you split the 6 as 2 times 3. It will all lead to the same answer. All right, so another example is this one. So here, what do we have here? Log to base b of 2 is 0.4. So here we want to find, just look at it now. This is the log, this is the base we have. This is base 2b, but this is base b. So it means we need to move from 2b to b. So this now we can write as this 2b, right? Equals to, or in other words, you need log to base 2b of what's of your argument. So log to base 2b of what's everything you have, b squared over root 2, right? By change of base, this is just going to be log of what? B of the same thing, b squared over what? Root 2 divided by log to base what? Still b of what? Of 2b. So now you can see we've changed the base. We've changed everything to b. So now we just need to simplify. This now we can write it as log to base b of what? B squared minus log to base b of what? Root 2. So now we are changing division to subtraction over, this will still be log to base b of what? Of 2b, right? Now, you always need to look at what you have. What do we have? We have that log to base b of 2 is 0.4. So let's rearrange this. This we can write as log, this will be 2 log to base b of b minus, this is going to be what? Because this is root 2. Root 2 is 1 over 2. And that 1 over 2 can come down. So this is half. This is just log b of what? Of 2. Divide by this now. This is 2b. Don't forget. So we can change it to addition. So this becomes log b of 2 plus log b of what? Log b of b. Right. So finally, we can now log b of b is 2. So you have 2 times 1. This is just 2 minus, this is half log b of 2. Log b of 2 is 0 0.4. So this is half times 0 0.4 here over log b of 2 is still 0 0.4. And log b of b is what? Is 1. So here is going to be 2 minus, this is going to be 0 0.2 divided by, I think this is going to be like 1.4. And what do we have here? This will be about 1.8, right? Divided by, let's say, 1.4, right? And here easily we can see that this is 18 over 14, which we can write as what? Is it 9 by 7? Yes, so this is just an application of what? Of change of what? Change of base. So your target is to go to 0 0.4. If you have log b of 2, log b of 2 is always 0 0.4. And we can substitute there. All right. So what next? Now let's look at this one here. This is log of 2. So it means you can see here, this is like saying you are given everything in base 10, but now you want to find something in base 2. So it's your choice. We can start by saying log to base 2 of 49 over 8, right? Directly, you can go to base 10, or you can do some simplification, but let's just change base directly. So this is going to be log to base 10 of 49 over what? Over 8 divided by what? Log to base 10 of what now? So sorry, we're going to base 2, okay? We're going to base 2, so but we need to go back to base 10, yes. So this will be base 10 of what? Of 2. So what we're doing here is that we have base 2, but I'm trying to convert base 2 to base 10. So this is it. Now, everything now is in base 10, right? Okay, so here now we can simplify this as log to base 10 of what? 49 minus log to base 10 of what? Of 8 divided by just log to base 10 of 2, which is already given. So you can see that things are getting clearer. Now, what is this one? This you can write as log to base 10 of 7 squared minus here, this is you can write as log to base 10 of what? 2 cubed over log to base 10 of 2, right? Now, what is this one? This is just 2 log to base 10 of 7 minus 3 log to base 10 of what? Of 2 over log to base 10 of 2. Now, what is log to base 10 of 7? Log to base 10 of 7 is y, right? But you have multiplying by 2. So this is going to be 2y minus 3. Log to base 10 of 2. Log to base 10 of 2 is x. So you have 3x over log to base 10 of 2 is still x. So you have 2y minus 3x divided by x. Okay. So that is it. Let's see what is example 9. Yeah. So for example 9, here we need to use some property because the bases are not the same, right? This is base 5, this is base 25, and this is base 5, all right? So, but if you look at the answers, everything is in what's base 5. So what can we do? We can maintain, we can try to write everything in the same base. This we can write as 3 log 5 of 2a minus 4 log. This I can write it as 5 to power 2 of b. And this we can still just leave it this way, 5c. Okay, now everything is in the power of 5, and we will use the property we discussed earlier. We discussed the property. We said that what if you have what did we say? If we have a base, if you have log to base ak of x. So what did we say? We say this is 1 over what? K log of a of what? Of x. So this is the property we're going to use now, right? So with this property, what is our k? Our k is what? Is 2, because this is 5 to power 2. So things will remain here. This is still 3 log of 5 to a minus. But what is k? K is 2. So here in the front of your log, you should have 1 over k. So this is going to be 1 over 2, right? Then times what? 4 log of what? 5 of b. Yes. Then minus 1 over 2 log 5 of what? C. So we're done with this one. So let's delete it here. So y, I can write it by just by the side because I know that log of what? A to power k of x is going to be 1 over k log of a of x. Okay, so now we can try to what? We can try to combine things because you can see this is also like a combination because you have 3 terms, it has become 1. But this, we can rewrite this as log 2 base 5 of what? 2a all to power 3 minus, here now, this is 2 divided by 4 divided by 2 will be 2. So this will just be log of 5, but now it's going to be b squared, right? Then minus half. No need for half. We can take the half up. So we'll have log to base 5 c of what? Half. This we can write it as log 5. This is going to be 8a cubed minus log 5 b squared minus log 5 c half. Right? So, and here what can happen is that this will become log to base 5 of, this will become division, right? So just 8a cubed divided by what? B squared. Then minus again log 5 c half. And then we change subtraction again to division. So this is finally log 5, 8a cubed over what? B squared over C half. And this is nothing but log 5, 8a cubed over B squared under what? C half. Everything will be in the denominator. Yes. So the answer is A. All right. So which question again? Question example 10. For example 10, we want to write what? We want to write this expression as a single, we want to write it as a single logarithm. Right, so what does that mean as a single logarithm? So look at this one. We will see that the bases are what? The bases are also different. We have base 2, we have base half here. So this we can write first as 3 log 2 of x minus log of, this is now 2 to power what? Half of y plus this we can also write it as 2 to power 2 of what? Z squared minus this, now we can write it as 2 to power minus 1 of 5. So look at it. We try to write every base to be of power 2. Now, because of this property, this is the property, we can rearrange things. If you have log to base a, k of x, it's just 1 over k log of a of x. This is very important here, because we're asked to write it in base 2, right, as a single base. So here we can write these as log to base 2 of x to power 3 minus this. Now this will become 1 over k. Our k here is half. So 1 over k is just going to be 2, right? Because 1 over half. And then you still have this one to base this. Plus, here our k is 2. So it becomes half here. Then you have log to base 2 of z squared minus, here you can see our k is minus 1. So with minus 1, 1 over minus 1 is going to be minus 1. So here becomes plus. And you will still have log to base 2 of what? Of 5. So I hope this properties is clear. Okay, so let me repeat again. Here the k is what? K is minus 1. So 1 over minus 1 will be minus 1. But already here is minus. So minus minus becomes plus. All right, so what can we do here? We can rearrange this as log 2x cubed minus log 2y cubed. No, y square, sorry, y square, because this is power 2. Then plus log to base 2 of z. This is z squared, right? So you can say z squared to power what? Half, right? Which would just be z. Then plus this can be this one. Now let's put the ones that are additions together. We can rearrange and write log base 2 of x power 3 plus log to base 2 of, this will just be z, right? Plus log to base 2 of 5, then minus log to base 2 of y squared. Look at this, all of these are just addition, so you can change everything to multiplication. So you have log to base 2 of x cubed times what? Z times what? 5, right? Minus log to base 2 of y squared. And this will just simply be log to base 2 of 5x cubed z divided by what's y squared. Now you are changing subtraction to division. Right. So we have a similar one here. So the similar one here, it's Now we have base what? Base 3. We want to go to base 3. So we will do it the same way. This will just 5 log to base 3. We keep base 3 minus 8 log of what? 3 square of y plus log 3 to power half of what? Z plus 1. Now, this 1, we can write 1, since we want to go to base 3, we can write 1 as what? Base 3 of 3. So this becomes log 3x to power 5 minus, here, we can apply that property. So this is going to be 1 over 2 times 8 log 3 first. Then plus, this is going to be 1 over half, right? So which will become 2 log 3 of z, then plus log 3 of what? Of 3. Now this will be log 3 of x cubed minus 4 log 3 of y plus the same thing, 2 log 3 of z plus log 3 of 3. Now this is log 3 of x cubed minus log 3 of what? Y to power 4 plus log 3 of what? Z squared plus log 3 of 3. Okay. So similar to what we did, you can still arrange that because you see we have plus plus how many? 3 parts. So let's put the pluses together. You can write it as 3x cubed plus log 3 z squared plus log 3 of 3 minus log 3 of what? Y to power 4. Now we can combine all the addition and change it to multiplication. So you will have x to power 5 z squared times what? Times 3 minus log 3y to power 4. And then you can go to division here. So this will be log 3. And what else? 3x to power 5 z squared over what? Y to power 4. So this is basically what change of base is all about. So this is very interesting. You can always change. So you can see here we also apply. There is a change of base here, but here you don't have to use the change of base formula. You have to use the properties, right? Because here the bases, you have to make all the bases the same using base 3. But you don't have to use the change of base formula. We just use this property here that if you have log to base ak of x is 1 over k, then log of a to what? To x, and we're fine. So I think this will be okay. There will be another video, part 3, and that will focus on solving the exercises here. All right. Okay. All right. So thank you for watching. If you have any question, you can put it in the comment section.